Hai, Assalamualaikum warahmatullahi wabarakatuh. We are from section 5 and we are in the group 2, and today we want to present about our PBL task, which is about sequence. Hai, Assalamualaikum. My name is Amir Arsyad bin Amir Hafiz and my matrix number is AA250089.
Assalamualaikum. My name is Aiman Hanis bin Muhammad Razal, holding a matric card number AA251320.
And my name is Muhammad Shamal Akir bin Azliam. My matric number is AA251689.
Hai, Assalamualaikum and a good day. We are group 2 and the title of our presentation is Arithmetic and Geometric Sequence. In civil engineering, engineers often work with systems or data that change over time. These changes may involve an increase or decrease in quantities such as distance, cost, and materials. To understand and predict these patterns, arithmetic and geometric are used commonly. An arithmetic sequence is a sequence where the change between consecutive terms is contained. This type of sequence is suitable for situations involving steady and uniform changes, such as increasing and decreasing lampposts, additional layers in constructions, and others. For geometric sequence, it involves a constant ratio between terms, and it is useful when changes occur by percentage or proportion. As an example, reduction, cost escalation, or performance growth over time. By understanding this sequence, it is important because they can help engineers plan projects, predict future values, and not only that, they can also analyze systems accurately. So in our report, we apply both arithmetic and geometric sequence to the task that we got. We explain the concepts, solve the problem, and verify the results using the Microsoft Excel. With this, it helps us clearly see the patterns involved and understand how mathematical concepts are applied in real engineering situations.
For the case study, our group assigned with a scenario of a mall installing an escalator. And now, we need to find out how much an escalator maintenance and spare part costs for a few years. So, the information for escalator maintenance are that the maintenance in the first year cost is 2,000 ringgit Malaysia. Then, the maintenance for escalator will increase every year, and the cost for maintenance increase 500 ringgit Malaysia a year. For a spare part, in the first year, spare part of an escalator cost is 1,000 ringgit Malaysia. We also know that the mall will buy the spare part for every year. The spare part cost will increase by 10% for each year. So, with all that information, we can calculate the total maintenance and spare part cost for over several years by using an arithmetic and geometrical formula.
Based on the scenario, this cost increased by a fixed amount of 500 ringgit every year. Therefore, we identify this pattern as an arithmetic sequence. In this case, the first term, or A, is 2,000, where the common difference, or D, is 500. First, we constructed the general formula for n term using the formula xn equal to A plus, in brackets, n minus 1 D. After substituting the value and simplifying, we obtain the final formula as n is equal to 1,500 plus 500n. Unlike the maintenance cost, the spare part cost increased by 10% each year. This means it follows a geometric sequence pattern. The initial value A is 1,000. Since it increases by 10%, our common ratio, or R, is 1.1. Next, the formula constructed based on the geometric model is Sn is equal to A R to the power of n minus 1, and we substitute and simplify to get xn is equal to 1,000 in bracket 1.1 to the power of n minus 1. Next, we needed to find the total cost of maintenance for the first 5 years. We used the arithmetic sum formula as n is equal to n over 2 in bracket 2a plus in bracket n minus 1d. By inserting n equal to 5 and known value into the formula, our calculations show that the total maintenance cost is 15,000 ringgit. Furthermore, We calculated the total spare part cost for a 5-year period using the geometric sum formula. Sn is equal to A in bracket R to the power of n minus 1 over R minus 1. According to our manual workings, after inserting value and solving the equation, the total accumulated cost is 6,105 ringgit and 10 cents. Next, we have verified our manual calculation using Microsoft Excel. As shown, the Excel calculation result were accurate and in line with our manual calculations. We also plot the graph to see the cost trends. As you can see, the line for maintenance is a straight line, while the line for a spare part shows a little bit curve. This demonstrates the significant difference between arithmetic and geometric growth in the long run.
So, for reflection, our group gained a stronger understanding in sequence and series chapter, as it is not just a theoretical formulas in textbook, but also a tool to solve a real-world problem. Then, our team also developed a technical skill as we tried to use Excel and spreadsheet to solve the problem. Other than that, we also increased our level in critical thinking and problem solving. And last but not least, this assignment taught us the importance of working in a group to achieve an effective communication and task distribution to complete the case study smoothly without any conflicts.